Okay, continuing with the review or chapter 12, which is Enterprise Resource Planning Systems. You need to know what an ERP system is. It's basically a system that integrates all the departments and consolidates all of that data into a single database, creating a central system which provides global access to information throughout the enterprise. Um, so you need to know the basic concepts, the architecture. Core components are the accounting component, production and operations, and then human resources. When companies buy, if they license an ERP system, those are going to be their core components. And they'll most certainly license other components as well, but those are the core ones. ERP solutions. Well, it's an integrated suite of applications, meaning your accounting module talks with your financial modules, your production modules are integrated with sales and accounting because they're all written by the same development team, and also they're all reading and writing to the same database, different database tables, but they are definitely reading and writing to the same database. So they are a logical solution if you've got incompatible applications. You've got an accounting system by one company, you've got a sales system by another, a production system by yet another. If you want a logical solution of compatible applications, an ERP system is absolutely that solution. And in the late '90s, when we were confronted with the Y2K issue, companies were looking to find a solution to replace these old legacy systems that they were worried were not going to survive the transition to the year 2000. Um, this was a way to replace these incompatible solutions that you had to develop middleware to integrate. Um, the global information sharing and reporting, that's that centralized database. Um, the fact that so much of your information processing is embedded in the software of this system and is being entered into a database which each of these software processes has real time or near time access to. It means that, once an event happens, every process or individual has got access to that information. And this supports real time or near time operations. Also, the fact that it's one developer, um, one software interface essentially, so the look and feel is going to be consistent. Um, and if you need to span if it's a global company, that consistent look and feel will also accommodate different language requirements as well. So all of this reduces training costs and affords a professional feel for the application. We talked about the enterprise-wide view, the benefits. These are the benefits. You should know the benefits of moving to a central database versus having all these different systems, these disparate systems with different databases. Um, you would probably be asked a question about that. Be familiar with the evolution of ERP. It evolved from MRP in the '70s to MRP2. Kind of have a general idea of what those are to where we are with ERP now. Um, uh, Again, embedding information work in software. Um, there's some automation. Some automation in ERP. Also supports cross-functional business processes, and by that I mean sales orders are cross-functional processes. Procurement or purchasing cross-functional processes, and um, these processes, because they're all embedded in software, process of taking a sales order, entering the information in, can then trigger a warehouse pack and ship, which can then in turn trigger a billing and a processing of payment when it's received, and if the product is actually returned, um, that in turn turns around and triggers a reimbursement. You also embed best practices in when you license one of these. One of the things you get is best practices for example, the industry regarding, like, for example, human resource management or financial management, or best practices in terms of managing inventory if it's the food industry, or um, retail industry, whatever industry the is using whatever company is using the ERP system, whatever their industry is. If you need to conform to certain regulations like SOX or HIPAA or ITAR, you want to shop around and make sure the ERP system does conform to those requirements, and so you'll have to do a little homework when your company will need to do their homework when looking at different systems. If you're in the arms business, you probably want to look at certain ERP systems for that kind of activity. We talked about the core components. One good thing to know would be the benefits and the risks of ERP. Um, Again, single database, enterprise-wide view of the data, financials integrated with accounting, ordering, customer order integrated with procurement so that customer orders can drive purchasing, supports cross-functional processes, real operating on real-time or near-time information allows you to reduce inventory and lower operating costs because your organization is more agile, more adaptable as an organization. Um, you can reduce delivery and cycle times, and you've got hundreds, if not thousands, of standardized processes that are embedded in software, so your organization operates with more consistency and conformance to policy and regulations. On the other hand, the risks, time consuming and expensive to implement these systems. The average timeline for mid-sized to large organizations is at least 2 years, if not more. The software may or may not be, um, well, the software itself does, very likely, there's it doesn't conform to the way the business operates. So the business is going to modify itself in terms of how you process accounts payables, or you pay, or you process receivables, or you plan production. You're going to conform to the way the software works. Recognize that this has become your digital nervous system. The organization has adopted as its digital nervous system a software product that is produced by a vendor. You are very dependent on that vendor to continue to maintain and evolve that software. That software, the licensing of it is going to be expensive. You're going to pay consulting fees because implementing one of these is a specialized skill, and it is not something that an organization, upgrading your digital nervous system is not something that a manufacturing organization or a big box retailer or um, a defense contractor or whatever the business. It's not something they do on a regular basis. So you're going to need professional help. It has way too many features. It's like Word. Um, Oftentimes you have to customize it to conform. There's always some key processes that the organization has that give them a competitive edge. And so sometimes you have to customize the software to work the way you want it to work. Um, training and involving users in the implementation is often where companies fail to adequately invest, which is why I have those in red, but that's really critical. The complexity of replacing your digital nervous system in an organization is high. So implementing one of these is an extremely complex endeavor. There can be challenges integrating with other platforms like CRM and supply chain management. I've got a link down here at the bottom that will take you to 10 famous ERP disasters, and some of the issues with those disasters are integration issues, as a matter of fact. You're going to be reworking processes, the way information work is carried on in the organization. There's tremendous rework that goes on. You do things differently. Um, there can be issues with scalability. Um, this is where it's important to research your vendors and pick the product that's going to meet your needs. Um, Scalability also applies to evolving the system into the cloud. And then you are going to need to convert data from your old systems and migrate it into the new ERP system. And that's not a small endeavor. Um, some general guidelines for successful implementation of an ERP system are things that you would associate with any kind of large project in a business. You need to secure executive sponsorship because evolving your digital nervous system is there's a lot of change involved. You're going to need the help from value added resellers or experts, consultants that help with implementing these, and they tend to specialize in the particular ERP systems. You're going to need to take recognize that this system is going to affect the entire organization, certainly end users, and over time you're going to evolve it. Integrating supply chain management, CRM, and ERP are really, really critical these days because um, it provides a clearer picture as to what's going on in the organization, and especially with supply chain management, not only within the organization, but within the ecosystem that the organization is operating in. So, some advantages of integrating ERP and CRM, and a couple of tools that are used for integrating EAI, which is kind of like a framework um for integrating multiple application, whereas middleware tends to target two applications and be a solution. For example, there might be a middleware solution between Siebel's CRM system and SAP's ERP system. And of course, cloud, you should be familiar that the ERP systems are evolving such that now there are cloud offerings, there are cloud only ERP systems, but there are also hybrid offerings whereby which you have an internal installation of an ERP system, but you also can have an ERP instance that's running in the cloud, which makes it accessible to those remote users who are working in remote offices or are out in the field and are using mobile devices. And they need access to the same corporate functionality that the folks inside um, the building or the business actually have. You should know what disruptive or sustaining technologies are. So, disruptive, a new way of doing things, but it doesn't meet the needs of the customers initially. Sustaining technologies produce an improved tech product that customers are eager to buy. And I would be familiar with, how great firms do fail in the face of disruptive innovation. It is not unusual for companies to consciously listen to the needs of their best customers, focus their investments on innovations that have the best returns, which typically are sustaining technologies, and often to be undercut by disruptive technologies, aka the example of Blockbuster versus Netflix. Um, Recognize that the internet, with which really is a global network, and its evolving standards and technologies, coupled with the World Wide Web, really created an infrastructure that once certain companies began using this infrastructure, my goodness, they really just simply transformed themselves. Since so much of business is communication and collaboration. Um, and we had this infrastructure, and there was this infrastructure available in these open standards, such that these businesses really could just rethink themselves and redesign themselves. Once some started doing it, it created inevitable pressure for the remainder of these organizations to do it. Uh, Probably you might get a question on what the internet, the history of the internet, if you will. There certainly will be a question since regarding what packet switching is, so I would be familiar with that. You also should recognize that the World Wide Web and the internet are not the same thing. The internet, of course, is older than the World Wide Web. The internet's been around since the 60s in some form or another. The internet is simply a network. The World Wide Web is a service that is delivered from a service machine, allowing the delivery of content and application functionality through a web server. You might see a question, definition questions on things like domain name services, hypertext markup language, which is the development language of the web. Um, Certainly, the reasons for the growth of the World Wide Web, I would be familiar with these. There was kind of a there was a kind of confluence of events that resulted in the explosion of the World Wide Web. It's the microcomputer revolution, continued advancements in networking and um, wired and wireless technologies, plus the web's open standards were continued to evolve. The networking standards evolved, the web standards evolved, and of course these standards were open, so there was no royalty charges for using them. You had the browser, which allowed easy access to web services. You had technologies like domain name services. Domain name services, of course, is the technology that allows you to enter in a name and resolve that name to a numerical address so that you can locate that resource on a network. the fact that collaboration and communication over the internet is so inexpensive. There's a variety of options: instant messaging, email, voice over IP. Um, Also, content is easy and is relatively easy to create. There are a lot, and there are a lot of options for presenting content over the web. Also, XML integration. The development of XML has made it possible to create APIs, that is, advanced programmable interfaces, such that now the applications you interact with on the internet are the result of a unification of API functionality from a variety of different sources on the internet. Um, and the fact that the web itself is becoming more and more like a database, aka the semantic web. Let's see, moving forward. You should know what the long tail is, what the advantages of e-business are. Um, Clickstream data, you might see that term. Clickstream data, of course, is representative of the information that can be gathered in a web space, if you will, a website. You literally can follow someone around and record everything they do in a digital storefront as opposed to a physical storefront. So that's a tremendous advantage because you can understand what their interests are, where they spend their time, and subsequently you can customize or personalize that interface um, and also make design changes to your website that are informed by what this data is telling you. Um, Disintermediation, reintermediation. Disintermediation models are models which eliminated distributors, for example, or retailers, or both. Reintermediation models are platforms that have introduced themselves as an intermediary that provides connection and information. So, for example, eBay is now an e-commerce platform. Amazon and Alibaba are marketplaces that bring together buyers and sellers. Airbnb brings together people who are interested in renting. They provide a space for non-traditional renters to rent their properties to individuals who are interested in renting them. Financial cybermediaries are obviously needed. You know, they feel a need for managing payments for services and products over what really is an open infrastructure, and we need to be able to do so in a secure way. Blockchain is a type of, if you will, financial intermediary. Chapter 14 is e-business defined. Topic number 1 is what is e-business, e-commerce. Um, e-business is building IT reinforced relationships with customers, suppliers, and other partners. You've got examples of e-business, and then you need to know the different types of e-business. B2B, you should know what maintenance, repair, and operation, or MRO procurement is, versus direct procurement. Um, know that supply chain management and supplier relationship management systems are pretty critical to large scale procurement today. Um, also, there are software solutions that provide or emulate marketplaces. So, marketplaces like Alibaba and Amazon offer market spaces that bring together buyers and sellers and offer the services that are needed in order to engage in e-commerce services such as logistics, e-commerce payment systems, and mobile commerce support. Uh, might see a question about reverse auctions. A reverse auction, a web space is an excellent platform for a reverse auction where, for example, a seller is basically selling a contract and bidders are bidding for the business. Um, and you can incorporate or integrate into the software functionality that allows the consideration of other elements besides simply what the price is. You know, it could be related to the quality of the product, being able to deliver on time and within terms, um, you know, other value added elements that um, go above and beyond price. Again, B2C, you should know the different B2C models. You should know what mass customization is. Mass customization is, again, a marketing and manufacturing technique that is being employed more and more today to customize products or to build to allow to afford customers the ability to build or assemble products to their customization. And this is one way that computer aided manufacturing coupled with web systems and other kinds of systems are offering customers this additional value added service. And again, if your competitors are doing it and you're not, you are losing. Consumer to business and consumer to consumer. You've got different e-business revenue models, content providers, sites that are intermediaries, sites that are online marketplaces. Again, Amazon, Alibaba are examples of those. Portals such as the search engines and providers of service, some sort of service, whether it's a stock trading service or providing video content service, and then transaction brokers. So you should be familiar with these. Be also familiar with the different revenue models and have a good idea when how our marketing with search works. Um, got a video here for Google's AdWords service. It's really about ad placements that are actually paid for versus uh, the production of natural search results. Viral marketing. Viral marketing, of course, is a kind of a form of word of mouth. Only viral marketing might be propagated via various communication platforms like instant messaging or social networks or wikis, um, or through web content. And so viral marketing is marketing through social networks. Also, a form of viral marketing is marketing via YouTube, or marketing via TikTok. Um, and I think that covers chapter 14. And with plugin V5, you need to know what the network effect is. And the network effect, of course, is the more users that are gain access to the network, the more they produce content, information, and services. There actually is a formula for the network effect. It's the number of nodes to the power of the number of nodes minus one, as far as the number of potential connections between the number of hosts on the network. A couple of definitions. What's a telecommunication system and a network system? Key with a network is it's got to have a staff. You got to have two or more computers computing or communicating with established standards. The basic principles of networks: must be a network interface, must have a connecting device of some type, switch, wireless access point, must be communications media. That could be wire, that could be fiber optic, that could be space. And then you got to have software. You got to have the protocol stack to move the information in and out of the computer. Um, yeah, you should know what switches and routers are, um, and the different types of networks, LANs versus WANs, LANs versus MANs, if you will, and then versus wide area networks. Of course, with WANs and MANs, both of them are generally going to have, for connection links, they're going to have third party telecommunications providers for connecting between those locations. You should know what a packet switching network is. Be able to explain it. Might be a good idea to be able to explain what a packet switching network is in a short answer question. Um, and there are a couple of network architectures you should be familiar with: peer to peer, where you have there's no central server. Each of the hosts connected to the network have the same rights and are responsible for their own security. And if they have resources, they can provide access to other nodes to those resources. Know what a client server architecture is. Know that a client server architecture is a type of distributed computing where basically the processing, data storage, and interface processing are distributed among different devices. Client server networks differ according to, again, where the business logic and the data management are reside. Do they reside on the server side? Do they reside on the client side? And you have different flavors of client server. As a matter of fact, it's not exclusive to um, these five types of models, but these are kind of a good visual of what we're talking about. You should know the different network topologies. Um, the bus, which is one of the oldest network types, devices that are connected by a wire essentially, and then you have a star, where we took that wire and we created an electric box, first called a hub, and now it's a switch. And there's the ring topology, and then you've got wireless. So be able to recognize those in a description or um, definition. You should know what network protocols are. Network protocols, by the way, are related or associated with, because there are rules about communicating on a certain type of network architecture. Generally, those rules are going to be associated with that architecture. So, for example, the bus network, um, the protocol designed to operate on a bus network, which was nothing more than a shared circuit, is the Ethernet protocol. And then you have which an Ethernet is really about how to arrange data on an electrical line or wire. This is an example of some of the protocol rules. You should know what TCP/IP is. TCP/IP, of course, is the technical foundation of the public internet, but also most private networks today. And there are a number of probably recognizable protocols that operate over TCP/IP. The OSI, simply a reference model for protocol design developed by the International Standards Organization. Know that we measure transmission speed on networks in terms of bits per second. We discuss a number of wired media. You should know the characteristics of these media. Electrical media um, tends to have shorter transmission distances because of resistance in the media itself. So coaxial and fiber optic, the data transmits. You have shorter data transmission distances because of resistance. So if you need to, you might need a repeater on the line if you need to go further than kind of the standard for whatever wire network architecture you have. Fiber optic, on the other hand, has some unique characteristics. It uses light as a signal. In addition to that, the light can travel much further distances than, say, electrical, up to 25 miles. In addition to that, it's immune to electromagnetic interference, unlike electrical signals propagated over copper. As far as wireless, we'll talk about wireless in chapter 16. You should know what broadband is. Broadband is high capacity internet or network service. It's not exclusive to the internet. If you've got a local area network in a building and it's got switching equipment operating at 10 gigabits per second, and the twisted pair wire accommodates that bandwidth, that's a broadband network. Um, Broadband relies on some kind of multiplexing or switching device that can establish many channels through the same media, and subsequently each one of those channels is propagating data. And the more you have, the more data the system will propagate. Um, you should know when I refer to a last mile technology, I'm talking about the phone line from the telephone from the telecommunications office. Um, and it's that last mile of those four wires with a finite voltage that is a limiting or a restriction, especially when you get into urban areas. So there are some technologies that work on that last wire. A modem, for example, does. If you have a phone modem, it's operating on the phone wire, obviously. DSL is another last mile technology that runs on the phone line, but DSL signals are propagated at frequencies that are higher than voice conversations, above 3,400 hertz. So it's a connection technology option as well. Um, And then there's some discussion of various network solutions in here. You should be familiar with those. Also, be familiar with leasing circuit solutions. When you have two locations you need to connect and you don't have the access to run your own wires and connect those locations, so you're going to have to go to a carrier, and you're going to have to do something like lease a circuit that connects the two locations. Or you might go with some kind of business services solution like frame relay or ATM, where you're connecting to the service provider's circuit cloud locally, and then with all the locations. And so, if you have 10 locations around the country and you're using AT&T, and AT&T says, okay, great, you just connect. We'll connect you locally to the CO, or the service, or the telephone office, and you will route your traffic through our network of circuits, and that traffic will arrive at whatever destination it's intended to through our network. Um, and so, you've got some comparisons in here, comparisons of the different connection types. You should know what the VPN is, virtual private network, which is basically an encrypted session through a network structure. It could be a public network like the internet, it could be a private network. Most organizations today use VPNs through even their private networks, and the reason is to isolate certain types of traffic. Um, a value added network is a network service. For example, maybe you use a company for providing connection between two locations, but to add value, they also manage your email, or they provide electronic data interchange services uh, that you will take that you use to do business with your suppliers. Voice over IP is propagating voice traffic over an IP network. There are distinct advantages for that. You go from from two sets of wires to one system, and all traffic is going over the data network. There's tremendous savings in administrative costs, because the same person managing your servers is also managing your PBX now, which runs in a server box. There are some issues with voice over IP. Mainly, it's you have to have backup power, just like you do for your data network, because it's not like the phone system, which has its own backup power source. In addition to that, you need to maintain a database of phone numbers and locations, um, because an IP address can be moved to another location, and there's really no way to tell where it is. You have to have some sort of database that informs as to where that is. Okay, and that concludes the review of the exam 3 topics.